To dig into the knowledge domain of continuous delivery, it's a good approach to investigate some of the common signs of maturity at different levels. We have distributed them from novice to expert, and we have categorized them into 4 areas or disciplines. The first one, build, is obviously an important factor in continuous delivery, and so is test, verification, and quality assurance. But we also see that software configuration management and the way that teams utilize their version control system has a very great impact on the continuous delivery maturity. And we even see that the way teams visualize and expose and report on their builds and test results is important too. We could even have added more areas such as system architecture or deployment, as they have a tendency to have a great impact too, but the matrix would grow too big for this purpose, so you will have to fit in that yourself. But when it comes to builds, the early signs of maturity is that there is some script being maintained, and developers use the script to build and verify before they check in to the integration stream. Typically, these scripts are executed on the developer's PCs, but often the team will have a build server running a nightly build. In the opposite end, if you're an expert, then your build is triggered by what happens in your version control system, and your build scripts are being replaced by build configurations. Your builds are distributed, and your dependencies and artifacts are managed. The whole build environment is probably based on virtual machines, and even the management of the snapshot and disk images of these machines is part of what is actually being orchestrated by the Jenkins CI server. When it comes to test and verification and quality assurance, the infant level, which is outside this chart, is when you rely solely on the developer's individual judgment of whether or not his contribution seems to be okay. From there, you move through unit testing and measurement of code coverage to more sophisticated metrics, such as static code analysis, which Jason will treat you on in a few minutes. Then to peer reviews, automated functional tests, automated deployment, advanced use of test data, up until the point where you as an expert has automated your full acceptance test and you rely on it. In software configuration management, we still see that there are teams outside this chart who uses tools that doesn't even support branching or versioning of directories, such as Visual Source Safe or CVS, but they are becoming rare. Early signs of maturity is when branches are utilized, even if it means that branches are mostly used for a variant of a label. Sometimes merges are quite rare at this level, and developers dread them. Slightly more mature teams will use branches more as a means to isolate bits of work for a shorter period of time until they merge back to the integration stream. At this level, merges are quite frequent and they are used fearlessly among the developers. The next thing we see is typically that commits and version control system are being tied to task and change management system, and the team starts to maintain data that will allow them to gain some kind of traceability overview. A quite advanced use of software configuration management is when companies implement pre-tested commits. This is a process that resembles pull requests, as they are known from popular open source communities, where a benevolent dictator, or Jenkins as an automated integration process, in our case, keeps the integration branch pristine and unbreakable. When it comes to visibility, it's really a matter of collecting and using and sharing all the information and statistics and trends that you can. You must visualize the state of the code and do it continuously. In the end, you will probably have monitors in your work areas, and finally you will share its information, not just internally, but even with customers and the public.